Okay, good morning. Alright, I guess we're still a minute early, huh? Let's see who shows up today. Alright, so today, dual credit lecture. We're going to be going over the Law of Cosines. Oh, I guess while we're waiting, there was a dual credit question, a homework question I wanted to go over. I'll go ahead and pull it up here just in case any of you had the same question. So hopefully y'all's week has been going well, going online. If you haven't heard, we are officially canceled through to early May. One more month of this. I mean, my hunch is that we're probably done for the year at this point. They're officially not having prom, seniors. I'm sorry. I don't know. Maybe y'all can do like an online prom and hang out and chat. I don't know. That sucks. That sounds crappy compared to real prom. But just please don't do the beach house thing. I mean, we've spent this long in quarantine. You're just going to ruin it if you do that. Okay, so one of these early questions in the 6-2 homework, right here. And even though your problems and your numbers are usually randomized, I mean, I think the side lengths are, but the angle measures are specifically picked in a way on this particular problem to say, it says type an exact answer using radicals. So with triangle sides with geometry shapes, usually we want decimals, just because, you know, we're actually measuring something like with a ruler or something. In this case here, we specifically, it says it wants an exact answer, so you need to leave radicals. You use the law of sines here because you actually do have angle A. If you know two angles of a triangle, you know the third angle of the triangle because they have to add to 180. So if B is 30 and C is 105, added together, that would be 135, so that means you have 45 degrees left for angle A. So it's kind of like a quote-unquote hidden piece of information that you can derive right at the beginning of the problem. A has to be 45 degrees. So when you set up law of sines, A is going to be 8 over sine 45. So let's actually write down the work so you don't have to keep listening to me. So it said side length A was 8. So you've got 8 over sine 45. So that's A over sine A. And then the problem here, and then this part will randomize, but it says use the law of sines to find side B. So you can do B over sine B, which is 30. Now normally we're just cross multiply dividing and typing everything into a calculator here, but sine of 45 and sine of 30, you can get both of those from the unit circle. So 8 sine 30 equals B sine 45. And both of those are numbers off the unit circle. Sine of 30 is a half. And sine of 45 is square root of 2 over 2. So here you get 4 equals B times square root of 2 over 2. And you can solve for B by dividing it over or multiplying by the reciprocal. So you get that B is equal to 8 divided by square root of 2. But you can't leave a square root on the bottom of your answer, right? So you rationalize this. And you get 8 square root of 2 over 2. And that part reduces to 4. So B is 4 square root of 2. So here they actually do want the radical answer. Okay. That does not happen very often. It's not going to happen on the test. The only reason it works in this particular problem is because they specifically set up A and B, the two angles that you need in the problem, to be two things you can look up on the unit circle. That almost never happens. So that was the homework question I got last night. Anybody happen to actually be awake in chat and have any questions? I've noticed the stream numbers are slowly dwindling as the week goes on. I've had plenty of students admit to me they just look at the YouTube recording, which is fine, as long as you're looking at the work. Okay, so I'll save that slide and post it along with this video, along with today's lecture. So we're going to be covering 6.3 today, the law of cosines, and then remember tomorrow, we will not be streaming. We are going to set up the Zoom video call. So at the end of the lecture, I'll give you a little bit of advice on how to get started. Make sure you have Zoom set up properly. I'm going to post a link to a Zoom meeting, and then, or I'll do it tomorrow morning, and then you just need to join. You do need a webcam and a microphone. If you're doing it on your phone, that should be good enough. Everyone has a face cam and a mic. If you're doing it on a computer, you'll need, hopefully your laptop has a webcam and a mic, but I do want you to actually log in and let me see you. So free homework grade for tomorrow. I have figured out all the details of what we're doing with that. So yeah, so tomorrow I'll give you all this information. But dual credit, I will take one of your homeworks from the previous 21 that we've done, and I'll replace your lowest homework grade with 100. So that'll give you a few points on your homework average. I mean, it's basically going to amount to a point or two on most of your averages, unless you just have like a 99 homework average. Pre-cal, pretty much the same thing. I will give you a free homework grade, a free 100 if you show up. If you don't show up, I mean, you're not going to lose out on anything. You're not going to lose out. I'm not giving you a 0 or anything like that, but it is a good chance to bump your grade a little bit. It is a daily grade, which is now 80% of your average. So it'll help you a lot if you don't have a 100 homework average. But also the main goal of tomorrow is for you to find a group, because it is going to be a group project. Group sizes have to be between 2 to 4. So you can't work by yourself. It can't be too big. Okay, let's get started with the law of cosines. So previously in 6.2, we talked about the law of sines, where 6.1 was all about right triangles. 6.2 was, well, not every triangle is a right triangle, so what do you do whenever you have a scalene triangle? The only problem is with the law of sines, everything had to start with a corresponding pair. You can't do law of sines without A and angle A, or B and angle B, or C and angle C. You have to have one of them. So with law of cosines, it answers the question, well, what if you don't have that? What if you have a side angle side triangle? Or what if you have a side 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 triangle where you don't have a corresponding side and angle? Are y'all hearing this? You can open the door. My kids are right outside the door. They want in very badly. Okay, so again, you don't have to memorize these, you just have to know how to use them, and notice how they all look pretty much the same. You don't need the second two. Really, you just need to pay attention to one of them, because the letters aren't going to be A, B, and C every single time you do a triangle problem. But what it's saying is that if you have little a, you can set it equal to little b squared. I mean, it kind of looks like Pythagorean theorem, minus 2bc times cosine of the angle a. The main thing to pay attention to here is the outside letters match. Whatever the side measure is over on the left, whatever letter that is, must correspond to the opposite angle over there on the cosine part of the problem. So we've got two different ways we use this. We can solve for little a, or we can solve for big A. If you have B or C instead, just swap the letters, use the corresponding version. So I'm going to show you both. And then the other thing I'll show you is why do you need law of cosines to begin with. So let's take a look at this example. In triangle ABC, find little b given that A is 2, C is 3, and angle B is 60 degrees. Okay, so there's the setup. If you had seen this problem in the last section, you actually would just completely be stumped because you can't set up law of sines here. You see why? Because remember, law of sines says A over sine A or B over sine B or C over sine C. So why can't we just use law of sines? Why can't we just do that? Well, because remember, I need A over sine A or B over sine B or C over sine C. I mean, we'll just go ahead and write the whole thing. If I try to set any of those two equal to each other, if I try to use a little c, which I'm given, I don't know angle C. If I try to use big B, I don't know little b, well, which that's what I'm trying to find. If I want to use little a, I don't have angle A. You can't set up an equation that only has one variable, if that makes sense. You don't have a pair of letters that are already given to you. So we cannot use law of sines in this problem. You have to do law of cosines. Now we want little b, so use the version that has little b off to the side. So b squared equals a squared plus c squared minus 2 times a times c times cosine of big B, which is 60 degrees. So if I plug in everything, even though it's a longer formula, it's actually less work because you just type all that stuff into the calculator. Okay, so let's do that. Oh, whoops. Gotta actually cancel out of this. Alright, so we're going to type in 2 squared plus 3 squared minus 2 times a, which is 2, you need 2 of them, times 3 times cosine of 60. And that's not the answer, that's what b squared is equal to. I need to square root to cancel that. So 2.6. You could have square rooted the whole thing whenever you started typing, which is what I'm probably going to do from now on, but yeah, you could have just square rooted to begin with. But there you go, side B is 2.6, and that's how you use law of cosines to find a side. Okay. Alright, so that's how you use law of cosines to find a side. The main thing here is to begin the problem, to even start. If I want little b, I have to have angle B. And then the a and c, honestly, the order that you put them doesn't matter because addition is commutative and multiplication is commutative. So the order that you put a and c doesn't matter. So, oh, and the reason I rounded to 2.6, just like last section, any decimal answer, it'll ask you for nearest tenth. Okay, let's find an angle. This one does take a little more work. Find a to the nearest tenth of a degree, and they tell you what a, b, and c are. So the unknown thing is angle A. The only one that has angle A is that top version. So notice how if angle A is the one in the problem, little a has to be the one on the left-hand side all by itself. There's only one thing squared over on the left-hand side. So A has to be the one that's over here by itself, 6 squared. B and C, the order doesn't matter. And then we'll just write everything the way it's supposed to be. And then we can have angle A be the only variable in the problem. Okay. All right, so a lot of calculator work again. Remember, this is the variable in the problem, cosine A. So you have to look at all the other numbers relative to cosine A. A really common mistake I see students make is they'll do the 3 squared, they'll do the 4 squared, which is pretty obvious, but then they'll try to add those together. So here it happens to be 9 plus 16, 25. And then you have 2 times 3 times 4, which is 24. So it's, let me actually write it out. What some students try to do here is they'll try to do 9 plus 16 minus 24, which is wrong. Because the 9 and 16 relative to a are being added, so you can subtract them over to the left-hand side. But the negative 24 is multiplied to cosine 8. It has to be divided over. You can't just add all those numbers together. So here what you end up getting is 36 minus 9 minus 16 divided by negative 24. Now, just like last section, whenever you are solving for an angle, you have to use an inverse. Now, luckily, and this is the nice thing about law of cosines once you get used to it, remember how inverse cosine can give you all angles between 0 and 180. There is no ambiguous case with law of cosines. Based on the given information, I just wrote under my overlay. Based on the given information for a law of cosines problem, there is never a possibility that you have ambiguous case. So you will always only have one triangle in these problems. Okay, so we're going to inverse cosine both sides. And that's what I need to type into my calculator. So head over to my calculator, inverse cosine, make a little fraction bar. We end up with 36 minus 9 minus 16 all over negative 24. We end up with 117.3 degrees. And again, logically that makes sense because A is the biggest side. It should have the biggest angle. So 117.3. This stylus really sucks, by the way. I wish I had invested in something better. Can't go to Best Buy to get it now. Okay, so with a combination of those two things, finding a side or finding an angle, along with law of sines from before, then we can solve any triangle now. It doesn't matter what they give us at the beginning. As long as they give us 3 pieces of information, we will be able to solve every triangle that exists in the world. I guess except for angle triangles. You can't really do those. Think like if you had like an equilateral triangle, you could just make it bigger, keep the same angles, and just make the sides as big as you want. So you can't solve those. But okay, let's solve the whole triangle here. Solve triangle ABC. They give you A, B, and C, and again, you run. You're going to see this in the middle of the exam, so you won't know what section it comes from. So you need to look at the given information to try to figure out which formula you need. So here, you always want to try to think, can I do law of sines? Law of sines is going to be the first kind of default method you want to use. And then you notice here, oh, well, I would try to do law of sines, but I don't have A and A, or I don't have B and B or C and C, and I can't derive that information. So here's where you go to level 2, where you figure out, oh, okay, then I need to do law of cosines. I have angle C, so law of cosines will let me solve for little c. So c squared equals a squared plus b squared minus 2 times a times c times cosine of c, which is 60 degrees. So I just need to type all that into my calculator, and I'm going to go ahead and square root ahead of time, just so I only have to type in one thing. And it says round each answer to the nearest tenth. So let's scoot this over. Oh, come on. So we get square root 15 squared plus 10 squared. I guess y'all can read. I don't have to recite everything. And we get c is equal to 13.2, which relative to the other side lengths, that makes sense. So 13.2. Okay, I've got one, but remember, this problem asked me to solve the entire triangle, so I have to find the other angles as well. How do you do that? Well, there are multiple options here, and they're all correct. You could head over to Law of Sines now, right? Now we have C and C and B, or I have C and angle C. So that sets up one of my fractions for Law of Sines. I try to stay away if I can. If I have the option for solving angles, I like Law of Cosines, and the only reason I like that is because, it doesn't have ambiguous case. You don't have to check both cases. If you end up hopping over to Law of Sines, you have, fraction equals fraction, you cross multiply, divide. You're solving for an angle, so you have to inverse sine. Now, I said earlier that only one triangle ever exists. That's true anytime they set up anything side angle side or Law of Cosines for you. Only one triangle works, but with inverse sine, you don't know which of the two ambiguous case ones works. So you end up doing more work because you have to check both triangles anyways. You know in your head, ahead of time one of them won't work, but you have to figure out which one. Sometimes it's your calculator one, sometimes it's the 180 minus one. So if you want to save yourself some headache, just do what we did a slide ago right here and just set up Law of Cosines again. I mean, it's a little bit more writing, I guess, but remember, Law of Cosines never has ambiguous case. So we need either angle A or angle B. Let's just find angle A, I guess. So we got A squared equals B squared plus C squared, which we just got, minus 2 times 10 times 13.2 times cosine of A. So again, the order of this relative to A is the 10 squared is subtracted, the 13.2 squared is subtracted, and the whole negative 2 times 10 times 13.2, that gets divided because it's being multiplied to A. So by the time everything is all said and done, A is going to be the inverse cosine of 15 squared minus 10 squared minus 13.2 squared divided by negative 2 times 10 times 13.2. And once you do a few of these, you'll get the hang of it. Really, some people just end up memorizing that organization of where those letters go. And again, I really like doing if I have the option, I like Law of Cosines to find an angle because it doesn't have ambiguous case. Alright, so we will just type in everything exactly as we see it. And if you're not doing the alpha y equals thing, be very, very careful with your parentheses because there's a lot of multiplying being done and there's a fraction inside of a parentheses. So you're going to end up with, nested parentheses. So be sure you have enough. 79.3 degrees. And then finally, the only thing we have left is angle B. You don't have to do this again because if you have two angles, you can find the third angle by doing 180 minus what you know because the three angles have to add to 180. So B is just 180 minus 60 minus 79.3. And I'm probably behind my webcam at this point. So 60 and 79.3, that's 139.3. So you have 40.7 left over. There we go. And that's how you solve an entire triangle. We're going to do one more example of this, and then we have a formula at the end as well. But this was a side angle side triangle. The other type of triangle you have to deal with is a side-side-side triangle. I don't see any questions in chat, so we're going to move on. Okay, side-side-side. Round each answer to the nearest tenth. you have to do law of cosines here. Again, if this were mixed up in the middle in the exam and you don't know what section it came from, you would have to try to see if you could set up law of sines first. You can't here. So which angle do you want to solve for? Doesn't matter. I like doing the biggest one first. So there is no difference here. But you have to do the whole solving for angle thing. The second step of what we did earlier. Alright, so we will... And here I put C on the left-hand side, so angle C is going to be the one in the problem. The 3.1 squared gets subtracted. The 5.4 squared gets subtracted. The negative 2 times 3.1 times 5.4, that all gets divided. So you end up getting inverse cosine of 7.2 squared minus 3.1 squared minus 5.4 squared. And then the denominator has negative 2 times 3.1 times 5.4. And remember, that 2 is just part of the formula. That 2 is a constant here. See, there's a 2 on every single version. Okay, so I know what to type in now. Head to the old calculator. Oh, shoot. Typed in a... It didn't get the y equals part. Alright, so 7.2 squared minus 3.1 squared minus 5.4 squared. Down here in the numerator, or denominator, sorry, make sure you're using the actual negative button right here. See my mouse cursor? Don't use subtract on the denominator. I'm sure y'all have seen that before. Oh shoot, I didn't do parentheses. So 100, this rounds to 113.0. Again, you have the option here. You could hop over to law of sines and do 7.2 over sine 113 if you want. You have to do ambiguous case there. One of those works, but only one of them will work. You just don't know which one. So I'm going to just stick with law of cosines again. I'm going to do the same thing, except I'm going to solve for B or A. I mean, you can pick whichever one. So solving for B is the exact same setup. I'm going to try to condense my work a little bit here. Except you've got to put the 5.4 squared by itself first. Alright, I'm going to try to make this. My stylus kind of sucks, so it's not going to look great. Oh, that didn't work. I'm just going to start over. Oh boy, okay. How do I fit this on the screen? Gotta see where my face is right now. We'll just do it right here. Okay, so we're just writing out our work. Remember, the 5.4 is the thing off by itself now. There we are. So again, the 3.1 gets subtracted, the 7.2 oh, that should be a plus. It didn't come out. The 3.1 gets subtracted, the 7.2 squared gets subtracted, the whole negative 2 times 3.1 times 7.2 chunk gets divided. So B ends up being the inverse cosine. And it's going to look really similar to what we just did, except the 5.4 squared is the thing that happens first. It's going to be very similar to what we just typed in. We're just going to swap the order of a few of these numbers. Whoa, 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 whoa. And this first 7.2 has to change to 5.4. So 43.7 degrees. And then again, of course, A is just the leftover. So A is 180 minus 113 minus 43.7. So those added together give you 156.7, so 23.3. There you go. There's all three angles. So that's how you handle a side-side-side triangle. So between this one and this one, that covers every type of triangle you need to solve with law of cosines. All right. I do have one more side-side-side example here, but the reason why you'll see in a second, it's not going to take very long. You've got 2, 9, and 5. Remember how I said earlier that I like to solve the biggest angle first, just as a personal preference thing? The reason why it's a personal preference thing is because you have some side-side-side triangles that don't work. Spoiler alert, this one's going to be a no solution. But why? Well, you wouldn't see it until you got to this point in the work, but if you try to solve the biggest angle first, you'll see it right away. If I try to solve for B first, this is the setup. Okay, and then cosine of B, and then we just do exactly what we did the last slide. You're going to see something weird happen when we do this. 9 squared minus 2 squared minus 5 squared over negative 2 times 2 times 5. And then, so that's what I want to type into my calculator. Oh, whoops. That's not a squared. Okay, so we're going to type in all our stuff. And there is a domain error. This fraction is bigger than 1 or negative 1, so it doesn't work in inverse cosine. So this is a no solution. You can't create a triangle that has those side lengths. If you remember way back from your geometry days, if you saw it ahead of time, then you could have just done it now. There's a thing called the triangle inequality that says if you add up any two sides of a triangle, it has to be bigger than the third side. So you've got something that's a length of 9, and then something that's a length of 2, and something that's a length of 5. It's like T-Rex arms. They don't reach anything. So they can't touch each other. You can't make a vertex. So here. And then we'll go. There we go. So you can't make a triangle with these side lengths. Okay. All right, so that covers all of your cases with law of cosines. Now we do have one more formula, and I know you're thinking, oh, another formula. It's actually the easier part of the homework. It's derived from law of cosines if you're wondering why it's in this section. If you're curious about why, you can always Google it, or I'd be more than happy to talk about it with you. But Herons Formula is a method of finding the area of a triangle. If you remember, in geometry class, area of a triangle was 1/2 base times height. Well, a lot of times we don't have the height of a triangle in these problems, right? They just give us side and angle measures. They don't give us a weird thing in the middle of the triangle that's the height or a perpendicular bisector or whatever. So only knowing the side lengths, you can derive the area using this formula. Square root of s times s minus a times s minus b times s minus c. And s is known as the semi-perimeter, which is just half of your perimeter. And everyone knows what a perimeter is. Just add up your sides. So you actually use these in the opposite order. Step 1, find the semi-perimeter. Step 2, plug it into Herons formula. And really, that's it. So here, you've got a triangle ABC. And the order you do A, B, and C doesn't matter here, which is nice. So round the answer to the nearest tenth. You have your 3 side measures. Oh, sorry. Yeah, we're done. So step 1, find the semi-perimeter, which is a half of your perimeter. And so that adds up to what? 54 plus 40 is 94, so 47. And then you want to plug into Herons Formula. So Herons Formula, and it's, again, just like Law of Cosines, it's longer, but as soon as you plug it in and type it in, it's just calculator work. So S times S minus A times S minus B times S minus C. And if you did S correctly, you should be able, S should be bigger than all of your side lengths. One thing you do want to check, before I get you the answer, something that a lot of people screw up here is they'll try to type it like this. Oh, wait. And I've talked about this before in class. Some people use S as 79.5, and that's wrong, because here what you're telling the calculator to do is only 1/2ing the 29. You have to be sure that you do parentheses if you're relying on your calculator for this. So you see S is 47. So let's actually do Herons Formula now. And you don't have to type the times between your parentheses. So 360.9. Okay. 360.9. Unit is actually inches squared here because we have an area. Technically, it's square root of inches fourth. But square root would just cut the 4 in half. All right. So there is your 6-3 lecture. Okay, so just to recap, Law of Cosines, we need it because sometimes the given information doesn't let us set up Law of Sines. So here are the two different math things we do with Law of Cosines. So when you solve a whole triangle, based on whether you're given side, angle, side, or side, 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 you're going to do some combination of those types of work. You could transition back to Law of Sines in the middle of these problems, but my warning against that is that you end up having to do ambiguous case again. If you just stick with Law of Cosines, you don't have to do ambiguous case. Sometimes you do get a no solution if it doesn't meet the triangle inequality. And then we have Herons Formula for solving the area of a triangle if they ask you for that, only given the side lengths. So that's it for the lecture. I will post this momentarily. So before we're done today, I do want to talk about Zoom. So again, the two requirements are that you are on tomorrow at 8 and that you join the Zoom meeting and you have a webcam and a microphone handy. If you're just using your phone, that's great. If you're using your school iPad, that's great. If you're using a home computer, it needs to have a webcam and a microphone. Most laptops, after 2015 are going to have that. But some of you are on gaming PCs or desktops or whatever. So you do not get your free homework grade unless I get to see you and hear you. You do have to participate. Just like, if you forgot how to talk to real people in the last 3 weeks. And then we're going to put groups together. And before you leave the meeting, the Zoom meeting on Friday, on tomorrow, then you'll have to tell me what group you're in. I'll share the rubric with you. I will share what we're doing with the project as far as planning, your theme, planning phase, question phase, product phase. It'll probably take about 2 to 3 weeks to get done. Okay. All right. It looks like I'm shutting off the video unless anyone has any questions in chat, which I don't see. And otherwise, I will see y'all tomorrow on Zoom. So no Twitch stream tomorrow.